Greetings and welcome. My name is Frank Coe. I am the lead instructor for the Electronics Tech program at Chabot College in Hayward, California. I'd like to introduce you to our exciting electronics technology program in this presentation. So let me share my screen with you. Let's go to here and share. Great. For additional information after this presentation, I can be reached at fko@chabotcollege.edu, and my mobile number is 415-279-6488. Let's begin here. Why electronics technology at all? Well, here we go. These are the ESYS job prospects as recorded by my research in Indeed.com as of February 28th for our local municipality in Hayward, East Bay area. And you can see a number of wonderful opportunities: San Leandro, Milpitas, San Leandro, Hayward, Menlo Park, San Mateo, and also right in the center of the screen, take a look at Tesla, our friends right down the freeway on Highway 880. And I do highlight a point of interest that they've made about experience being a plus with respect to FANUC robot experience, which we'll be talking about more in a little while. The salary ranges are very attractive for electronics technology graduates. So let's take a look at some additional information. This is U.S. Bureau of Labor Statistics as of May of 2019, and some specific code numbers that may be of interest to people who are looking to compare these to other career opportunities: electrical engineering technology technicians, electromechanical and mechatronics technology and technicians, calibration technologists, all have very, very good prospects. In addition to that, more detailed information regarding two particular categories: electronics engineering technicians, electromechanical technicians, are all looking pretty good. And most exciting is the top codes, the taxonomy of program codes that are supported by our electronics technology program here at Chabot College. These would include 0934, electronics and electronic technology, with the details as shown here. 934.10, computer electronics. 934.20, industrial electronics. 934-60, biomedical instrumentation. 935, electromechanical technology. 943, instrumentation technology. 943.30, vacuum technology. 945, industrial systems technology and maintenance. Our discipline touches on many aspects of this range of top codes of the industry. And our electronics technology program is comprised of 7 core courses totaling 21 units towards an Associate of Science degree that will total 60 units. And the courses are shown here as ESYS 50, Introduction to ESYS, ESYS 51, Fabrication Techniques, ESYS 54, Analog Circuits, Semiconductor Devices, ESYS 55, IoT, which is Internet of Things, microcontroller systems, ESYS 57, PLCs and process control systems, ESYS 63, IT Essentials. This is your PC hardware and PC software. ESYS 69, which is a brand new course focusing on robotics and industrial control systems. And we also have, very proud to introduce the ELVIS as part of our Benchtop system of components. So let's go ahead and run this here. This goes to show the screens from Tektronix, from the Tektronix oscope. The oscope is reading information that is coming off of various parts of the circuit board under test, and the traces are ported into the ELVIS from National Instruments. We're very blessed to have these machines in addition to our benchtop machines for our students to use in the laboratories. In addition to the ELVIS, we also have outstanding benchtop machinery, starting with the function generator. It is a Fluke 271 function generator. We have our Tektronix desktop power supply and a 4-channel input Tektronix oscilloscope. So the same circuit that you saw earlier with the NI ELVIS, we're utilizing that board, and the probes are now simply connected to the function generator and the benchtop oscilloscope. So our students learn hands-on with real instruments as well as with the electronic simulator. And the outstanding further connection here is that screen that you see here on this oscilloscope is also set up such that the students can capture that information in software and transfer that onto a report document of their choosing. And we'll also focus a little bit on this one particular opportunity, a robotics technician. I pulled this off of the Bureau of Labor Statistics, and as of 2016, all the numbers look very favorable. And if we look at a testimonial given by a robotics worker in the industry, and outlined in red, every day my job would be teaching a robot. What do they use to teach the robot with? Something called a teach pendant. A teach pendant is shown on the left-hand side of the screen. This is the device that we would use for programming a robot. And the technician also further notes here, after you've learned one language, you can pick up others because all robots are set up about the same. And that's very, very true. Let's take a look at the next. Here is the brochure for our newest course in our program. This is ESYS 69. 69 includes robotics and industrial control systems. So we're using two training systems. One training system from FANUC, worldwide renowned for their robots that are used in industry, and also Amatrol for motor control systems for our students to learn how conveyor belts and automation systems in airports and assembly factories all work. And here is further brochure information. Very excited about this and all the topics that are discussed between motor controls and the FANUC robot arm. Now, most exciting is this. This is our actual lab, and it goes to show our motor control system. As well as our newly acquired FANUC robot arm. So that's the FANUC robot arm, and this is the teach pendant that is used for programming, and this is the same teach pendant that's used in industry for programming various FANUC robot arms. And why robot arms? Well, this will give you an indication why and how popular robot arms are used in manufacture. Their most impressive robots, the Wolverine, the Claw, and Iceman. Love their names. And if you look at this still, that's a FANUC robot right there. So what we have in the classroom is just a smaller version of that guy. In addition to that, we also offer an opportunity for the students to earn certification in the operation and programming of the FANUC robot, which is really exciting, as well as CompTIA A+ certification for their proficiency in understanding computer hardware as well as computer software. So industry recognized certifications are a real big plus for our students going into the job market. Here is another system that we use for training. This is from our friends at SMC. This is called the IPC 200 Industrial Process Control Training System. It is made up of 3 modules. We have the 201 station, the 202 station, and the 203 station. The 201 station simulates bottling, mixing, fluid production. The fluid is then transferred over to the 202 station, which simulates bottling, containerizing, and then the containers are then transferred over to the 203 station, where palletizing is learned. We have 2 complete sets of these 3-station IPC 200s, a very exciting training system that we're very, very blessed to have for our students. And our own IPC 200 is demonstrated in our labs here. So you're seeing the combination of the 202, 203 station, the containerizing of the fluids, and then the palletizing of the containers into the pallet. So as the students learn the programming and connections of the PLCs are these devices here, programmable logic controller. These are industrial computers that the students need to learn how to control, program, and the upshot of this hands-on training with these machines is with the projects that are very, very exciting for us to share with you. So here is one team project utilizing PLCs, programmable logic controller, with a drawbridge automation project. So here is a train that with a push of one button starts the sequence, and after that one button is pushed, everything else is completely automated based on timers and sensors and such. This train will move forward. When it reaches this point here where the sensor will detect it, the train will stop and await for the drawbridge to raise. Once it's raised to the appropriate height, then the train will proceed. And there's another sensor on the other side of the drawbridge that once the train passes that sensor, the drawbridge will then come back down. And then the process will reverse itself. This is really quite an exciting project.
This arm came down beautifully.
Like it on this side.
An Alameda, right? Yeah, well, that's ours. So we have.
We had a second auxiliary contact. That way I didn't just jump right across the second contactor. That might have been able to resolve that issue as well. This is all.
A little limit switch right here?
Yep. Actually, originally it only had one limit switch. But Todd was able to procure a second set.
Where's the other one at?
No, it's right next to each other.
See, they're double.
They're double. Each one are double.
What do you need the second one for?
One is for the power of the motor. And then
Reverse it?
Huh?
Is it reversing it?
No. Well, yes and no.
And I might add that these are not kits. These are completely conceived by the students, and various parts are purchased and assembled together. But this is not a pre-designed kit. The students came up with the scenario and built all of this. Another project is demonstrated here with this team. Go press play
Okay, so this is.
and go to the 2-minute mark. Right here is good.
For portability.
Because we wanted to have water, we really want water to run through. We
Yes.
wanted to prevent any electronics from that. So if
Yes.
water was gonna like spill,
Mm-hmm.
the gravity will go down and all that.
And not harm your electronics. No, it's a well-conceived, well-designed, well-built project. That you have a support shelf for your electronics and then your relays. So yes, everything is safe.
And we did try to get rid of the relay for the smaller ones. However, they couldn't communicate with the
We should try that in there.
Mhm.
It didn't work, so we just go back to this. We know this works.
All right. All right. All right.
And what Walter has to share with us in a moment really encapsulates what the learning experience with team projects is intended to convey to students.
Fantastic. Walter, you have something to add, I'm sure. Yes.
For sure. So the entire thing was a learning lesson for us because we incorporate all the material that we learned from the class, and then we use some extra research so that we can understand it much better. So,
Yes.
by doing this, it's kind of like an open up ourselves, just kind of get more on the advanced, learning more about the PLC, and then I'm pretty sure some of my colleagues on the project we're gonna just kind of advance this
Mhm.
to the student level so that
Yes.
we can just kind of understand more in details on how the PLC works.
That's good.
That's great, actually. All right, here's another team project. Very exciting. HVAC.
Because
Go to 220-ish. Find that time mark.
That switches as a multicolor LED.
Yeah, it's RGB.
Oh, nice. Very, very nice. Nice relays, everything. Okay. Fantastic. Yeah, just switched. Beautiful. And then inside, oh, the magic box. Oh, yeah. It's a little grid sensor. White grid sensor instead of a blue grid sensor. I love it. I love it. So the cold air comes in this tube, and then this
This will return.
that's your return. All right.
So what were you using that fan for in the back?
that's the outside air.
Exhaust.
So actually we have like a two-stage actually. The section,
So the exciting thing here is they built a conference room office with a HVAC system with a thermal sensor in the room. There's your thermal sensor, fans, as well as air conditioning via a dry ice container. So when the temperature in the room heats up based on the lamp creating heat in this room space, once a certain temperature has been achieved, it's deemed to be too warm, then the lamp will go off and the air conditioner blower will blow cool air from the dry ice container and cool this. And once the temperature comes down to another preset point of interest as determined by the sensor, then the air conditioner blower will shut off and the incandescent lamp will turn back on to heat the room back up to an appropriate comfortable temperature. The thermostat control is programmed by the students into the PLC. A fantastic project. Next, we also have in our ESYS program a wonderful fabrication course, and part of the fabrication course engages students in learning how to solder down to the surface mount technology, SMT level, how to do laser cutting, 3D printing. And so here's an example of the laser cutter. Go to this time mark is great. So they program the laser cutter to do different things for them. And part of the laser cut projects will include containers for their solder projects, of which this is one. This is the surface mount technology project that they hand soldered. We don't have a solder bath, so the students hand soldered each of the components. These are SMT resistors, surface mount technology resistors, SMT LEDs, surface mount technology LEDs, and very, very carefully done by hand. If we have enough funds from in the future for our solder bath, and we'd like to include that as part of our growing program needs. But this is all very exciting as part of our fabrication side of the program. Here's another side that's very exciting, and that is design for 3D as well as printing in 3D. So our designs are conceived by the students using various pieces of software. Tinkercad is one of them, Onshape is another, or SolidWorks is another, and they design this way. Here's an example of one done in Tinkercad. So let me scoot this up to the appropriate time mark. That's good enough there. I've also got in here a hole through. So these are holes that are carved in showing FCNS by KO, and I've got a little hex opening in here for a little more creativeness and also to lighten the visual appearance of this block of 3D printed material. So that hex does go all the way through. And then let's see from the underside. Yeah, my lettering does not go all the way through. My lettering is just simply indented, if you will. And so the elements are, I start off with a rectangular block, and I start by creating. And then once the design is achieved, then we actually bring it to the printer. And here's our printer creating the work. Now let's go to this time mark. And this is one of several laser 3D printers that we have, and one of several kinds of 3D printers that we have. And after the object is printed, then the finished object could look something like this. That's a cell phone stand that we've illuminated. And other fabrication projects include a DC motor build project. And this motor build is really fascinating in that it starts off with the D-cell battery, 2 safety pins, a rubber band, a couple of magnets, and a hoop of transformer wire. Watch what they have done with this.
Good angle. Look at that. We have 2 motors working off of 1 stack of magnets. Look at this. Last year we were able to get 3. Yeah. Now, without moving your hands, turn around and wave at us. Hey, good job, my friends. That's great.
Okay, and we also host field trips from local high schools to get students excited about electronics technology. And here are 2 separate groups that came by this past semester.
Yay. Got some LEDs. Yay. All right. All right. You got something to be able to take home, show mom and dad. Yes? All right. Fantastic.
And so in the hosting for the 15 minutes that we have per each group, the students were introduced to the concept of voltage and resistance and current, built a simple circuit, and then they also built an LED circuit that would change into multiple colors that they would be able to take home and show mom and dad. Here's another group.
Wave. Look at those bright LEDs. Nice work, everybody. This is great. All right, fantastic.
And one more with our high schoolers.
Look at that, it's going, yes, yes. One more over here. Oh, look at this. Whoa, Jacqueline's got a motor working. It's like, it's alive. Look at that. Is that cool or what? She made a motor.
Yay. So here we go. Are you ready to pursue your career in electronics technology? We try to create an environment that makes it fun for you, that makes it mentally stimulating for you, and also will challenge you, as well as give you career advancing with real world skills to meet the demands of the job market. So if you're interested, please contact me. I am Frank Coe. I'm the lead electronics technology instructor. My email is fko@chabotcollege.edu. And my mobile number, you can see on the screen, is 415-279-6488. So with that, thank you very much for your participation. It's been fun to share this time with you.